AWS and Cloudflare were hacked in the year 2023. Imagine if we store passwords as they are in our database. What happens when hackers get access to these passwords? In this section, we would be looking at one of the most important back-end concepts and security concept as well. This is hashing. My name is Niafote and welcome to this section of back-end engineering. Now, what is hashing? So I'm having this simple code over here and Alice has saved her password as password 123. Bob has also saved her password simply password, and most of us like doing this actually. Now, let me quickly run this and let's see what we get. So we have node server.js and we get Alice's password and Bob's password as well. Now, one thing we should know about hashing is that first, at the end of this section, we will know what hashing is, okay? Why we never store raw password, what makes a hashing algorithm secure, and why bcrypt library is one of the industry standard tools for hashing. Now, hashing is not reversible. Hash passwords are not reversible. So let me quickly uncomment this section and let's look at a function and can you tell me if this function is reversible or not? So we have x plus 7 and we are finding the modulo 100. Did I say right? Apologies. I'm not a mathematician, but we have this function here and we are having the reverse hash or the reverse function also over here. Now, this is not a hash function. It is just a function that can be reversed, uncharacteristic of hash functions, right? As I said, this is not a hash function. So let's quickly run this and let's see what we get. So node server.js, and we can see that when we have an input of 42, when we pass the input into the hash function, this hash function called hash, right? This code is in JavaScript. If you don't like JavaScript, apologies. I'm having a server.py here, but I think I'll just ignore it for today. We get 42 for our input and a hashed password of 49, right? I'm just using numbers to explain this concept. Now, since this has a reversed function, right, hackers can like try and get some trend or something and get the reversed form of the password. Now, once they get one, of course, they have the function to reverse form and they can easily get everything. Okay, that is why we use hashing. Hashed passwords cannot be reversed. Hash functions cannot be reversed. That's why everyone hashes the password nowadays before saving in the DB. So now in this the second section, we are going to look at one example of a hash function and how they work with the bcrypt library, right? So let me quickly comment out this section first and take a deep look at this. Okay, it's very, very, very important. Pay particular attention over here. So let me clear this real quick and let me run my server node server.js. Now we are having this hash, right? We are hashing this raw password 2 times. We are not hashing it 2 times, but we are running it we are passing it through the same function 2 times. And as you can see over here, we are getting 2 different functions. We are getting 2 different passwords. Sorry. One thing we should know is that when we apply a hash function, when we pass a password through a hash function, we get the same hashed password. But with this bcrypt, the bcrypt adds something called a salt to the hashed password. So what this salt does is that it adds something like a random value to the password before passing it through the hashed function. Now, once you store this in your DB and you are trying to log in again, the hashed password contains a salt, and the salt actually tells the bcrypt algorithm how to get a password back. Okay, so every salt which is random has a way of getting the password back. That's one thing about salt. It's attached to your password. It's usually the section after the dot sign, right? So we can see that we are having two dots here. I don't know the dots in the first section that contains the salt, but the salt actually contains a way to tell the random source that was added before the password was hashed. Okay, I know it's a bit confusing, but you can do a bit more research on it, and I have a video on salt. You can click on the description below to get that video and also understand what the salt actually means. Now, in this third section, you're going to explain why we can't reverse hashed passwords. Okay, I know it's getting a bit boring, but just stay with me. This is the last section and you are going to love it. Now, we are having this simple hash function. We multiply the input by 7 and we add 13 and you find the modulo of the value that we get. Now, we are having this sample inputs 12, 25, and 12 again. And let's quickly run this code and see what we get for our answer. Now, we see that we get 97 for hashing the 12, 88 for hashing the 25, and 12 for hashing the 97. Now, the reason why we can't reverse these function is that it's not possible for us to reverse. No hacker can reverse these kind of functions. So we have types of function called one-way function, and they have there are functions that actually have no inverse. Okay, so they can't be reversed. They are actually functions that work that way. I'm not a mathematician, but you can look that up and see what this means. So this is why hashed passwords are actually secure. They cannot be reversed. You can't get a simple function to run to get every hashed, to get every password back or to dehash a password. Okay,